values for a makes the expression 2a plus 5 over a squared plus 1 undefined. Which one? So undefined, that's what we're looking at. When I have this question here, I'm going to take the denominator, a squared plus 1, and set it equal to 0. I'm going to solve for a, and so that means subtracting 1 from both sides, and I get a squared equals negative 1. I take the square root of both sides, and I get that a equals the square root of negative 1, and so that tells me that a is equal to I, an imaginary number, and that is answer choice E. Now, why does that work that way? First of all, we have to go back to our question. We're looking at where this expression, which is a rational expression, it's in a fractional form, where is it undefined? And there's a couple of rules that you need to think about with expressions being undefined. And one of the things we want to look at is when we have a fraction, you cannot have 0 in the denominator. We know that if you're just looking at numbers, 3 over 0, that's undefined. We cannot do that. 5 over 0, 1,000 over 0, that is undefined. So we cannot ever, even in a variable expression here, have 0 in the denominator. Anytime I'm looking for what makes an expression undefined with variables, I'm going to look, first of all, does it have a fraction? And then I set the denominator, the number, the expression on the bottom, equal to 0. And that's what we did here. As a note, another place where an expression could be undefined is if you have a square root. So that's another area to look at. This has to be greater than or equal to 0. We're going to get into what our answer is, and that's imaginary numbers. So this is another type of expression we would want to be looking at what is under the radical if we're asked where it's undefined, and that would be where 3x plus 1 is less than 0, making it negative. And then we would go through and solve for x in that particular case. So the two cases for an expression being undefined that you could possibly see on the ACT is if you have a fraction and we don't want the denominator equal to 0, or under the radical if it's less than 0. Now, this imaginary situation, this under the radical being negative, came into play in our question here. And as we were solving this denominator, setting it equal to 0, we found we needed to solve for this a squared. And to do that, we take the square root of both sides, but we had a negative number on the right-hand side. But by definition, the square root of negative 1 equals I, imaginary number. That is a definition. Sometimes they will specify that for you on certain questions. Maybe if you're expanding out binomials and they include imaginary numbers, sometimes I have seen them give you this definition here. But in this case, you had to know that you were going to get A equals I for this particular thing because we got the square root of a negative 1. So if you're looking for more practice on questions like this, take a look at rational expressions, specifically looking at the denominator and where it's undefined, and you may even want to look a little bit into imaginary numbers at this point. This is your math question of the day. We have lots more videos to help you prepare for the math section of the ACT. Subscribe so you'll get our next practice. Until then, practice a bit more on your own, and when you take the test, you'll be glad that you did.